Okay, it's Mr. Martin. I'm going to work problem number 14 from your homework this evening. Found on page 83, you were to do 12 through 16, so this is just problem number 14. It reads 41.3 grams of iron nitrate in 100 cubic centimeters of solution. I want you to find the molarity. So here we go. We were working a little bit of this in the class today, so we're going to quickly review so that we can move through it. Molarity. Here it is. Let me write a better one than that. That's better. Molarity, capital M. It stands for moles per decimeter cubed. It's the number of moles of the solute, which in this case is the iron nitrate. And so we need it in moles. We have 41.3 grams, so we're going to change it to moles. And then it says in 100 cubic centimeters of solution. So the solution here is the decimeters cubed. That's 100 cubic centimeters. We need to change it to decimeters cubed. So what we'll do is we'll change that first, and that'll be the denominator. Remember I said in class, like to tackle each one at a time. Moles comes from the grams of iron nitrate, and decimeters cubed comes from the volume of solution, which in this case is 100 cubic centimeters. So let's do a little bit at a time. So we'll do the first one here. 100 cubic centimeters is how many decimeters cubed? That's the first question, and so we need to change it. And by using King Henry David usually drinks chocolate milk. The C for centi is chocolate, and the D for deci is in drinks. So it'd be one shift to the left. However, it's cubed, so it's 3 to the left, and it would make your volume 0.100 decimeters cubed. You could also change this to milliliters and this to liters, and it'd still be the same shift. So we'd end up with 0.100 decimeters cubed. So there we have it. We have our denominator. Now we need to change this to moles. So in order to go from grams to moles, we need to use our periodic table. So here's how it works. I have one iron in the compound, just one iron, and I'm going to write out its mass. And I found it to be 55.9 grams per mole. And since there's only one, it'd be 55.9 times 1, 55.9 grams per mole. That's what I would get. Okay, let's keep moving on. Let's go on to nitrogen. I have 2 nitrogens, and each one is 14.0 grams per mole. And so I would take the number 2 times 14, and that gives me 28.0 grams per mole. Okay, moving on. Let me see here. I'm going to move my board up a little bit. All right, so then I have here 3 oxygens, but times 2 gives me 6 oxygens total. Here we go, 6 oxygens, and this becomes 16.0 grams per mole. This would be 96.0 grams per mole total. I take the 16 times the 6. Okay, so now that you've got them all individually, we add them up. And when I totaled these all up, I got a 179.9 grams per mole of iron nitrate. Okay, so now we're all set. I'm going to get a new page so that we can convert these 41.3 grams of iron nitrate to moles using the molecular mass. So here we go. All right, so let's start with our 41.3 grams. 41.3 grams of iron nitrate. There you go, and I'm going to use that 179.9, but remember, since there's grams in the numerator here in my conversion factor, I want the grams in the denominator. So that means the moles, what I want as a unit, would go in the numerator. And then my grams down here, 79.9 grams of iron nitrate. And it would also be moles of iron nitrate. Don't forget your units. Don't be a unit hater. Okay, so now this is all written out. Now all I have to do is the math. So it's 41.3 divided by 179.9, and it gives me, and I'm going to use significant digits. Remember, I can only max out at 3, so I'm going to round, and it becomes 0.230 moles of iron nitrate. Okay, so now I'm going to use the same page, but I'm going to jump back to the other one really quick so that you can see what we got going on. So now I have moles from the other page and then decimeters cubed from here. So now I'm going to use this formula here, moles per decimeter cubed, and I'm going to give you the molarity. So let's go back. So I'm going to solve for it. What's the molarity? That's the question. So the number of moles is right here, 0.230 moles of iron nitrate divided by 0.100 decimeters cubed of solution. And so just a little bit of math here. When you divide by a fraction, in this case here it's a decimal, same as a fraction, it's 1/10. So you imagine 1 over 10. It's the same as multiplying by the reciprocal, so it'd be multiplying by 10. So this makes this 2.30 moles per decimeter cubed of iron nitrate. So, and it tells me it's in solution. Just having the molarity tells me it's in solution. You can also write it like this: 2.30 capital M for molar of iron nitrate. There you have it, kids. We solved the problem. Here's your final answer. Please circle your final answer. All right. So I hope this helps out, and I look forward to seeing you guys tomorrow. Good luck, best wishes, and good night.